It began as a dream shared across nations, a mission so ambitious that no single space agency could build it alone. In the 1980s, scientists and engineers from the United States, Europe, and Italy gathered around a single vision: to send a spacecraft to Saturn, the most ethereal of the planets, and to orbit it long enough to watch its seasons change. From that dream emerged the Cassini-Huygens mission, a marriage of precision and poetry. NASA would provide the Cassini orbiter, the European Space Agency, the Huygens lander, and the Italian Space Agency, the antenna and communication systems that would keep Earth connected to a world more than 1 billion kilometers away. It would be the most complex interplanetary mission ever attempted, a cathedral of technology built to reveal one of nature's most sublime creations. Launched from Cape Canaveral on October 15, 1997, Cassini carried 12 scientific instruments and a 320-kilogram probe named Huygens, nestled on its side like a small golden seed. The spacecraft weighed more than 6 tons, too heavy to fly directly to Saturn, so engineers plotted a 7-year interplanetary slingshot. Cassini looped once around Venus, then again, then past Earth itself, using gravity assists to build momentum, and finally skimmed past Jupiter in late 2000 for a last gravitational boost. Each encounter reshaped its trajectory, each planet lending part of its energy to the journey. By the time Cassini reached Saturn in July 2004, it had traveled over 3.5 billion kilometers, a voyage as long as it was precise, guided by radio signals that took over an hour and 20 minutes to cross the void. As Cassini approached, the planet grew from a pale dot into a glowing world ringed with light. On June 30th, 2004, the spacecraft fired its main engine for nearly 2 hours, the Saturn orbit insertion burn, and slipped silently into orbit. Humanity had arrived to stay. For the first time, a spacecraft would not merely fly past Saturn, but live among its moons and rings, watching the planet through cycles of sunlight and shadow. The first images defied imagination. Saturn's rings, seen from the night side, glowed like fire halos as sunlight scattered through them. Shadows of the planet stretched across the rings like cosmic sundials, marking time in kilometers instead of hours. Beneath that grace lay motion and violence, storms the size of continents, winds blowing at 800 kilometers per hour, and clouds patterned in endless bands. Cassini's instruments began their work immediately, scanning, measuring, listening. It became an observatory in orbit, chronicling a planet of storms, symmetry, and secrets. Among Cassini's earliest triumphs was its exploration of Titan, Saturn's largest moon and one of the most enigmatic bodies in the solar system. Titan had long been shrouded in an orange haze of hydrocarbons, concealing its surface from telescopes. Scientists suspected it might host lakes or even seas of liquid methane, but no one knew for sure. That mystery would soon be resolved. In December 2004, Cassini released the Huygens probe, setting it on a 3-week trajectory toward Titan's thick atmosphere. On January 14, 2005, Huygens entered the haze, descending by parachute for more than 2 hours while transmitting data back through Cassini to Earth. What it revealed was astonishing. Rivers, valleys, and lake beds sculpted not by water but by liquid methane and ethane. Pebbles of ice littered a surface that glowed dimly under a dark orange sky. Winds howled through the haze. Methane rain fell in distant storms. For the first time in history, a spacecraft had landed on a moon of another planet, and not on rock or dust, but on a world that mimicked Earth's hydrological cycle in alien chemistry. Titan was an Earth in cryogenic disguise. It possessed dunes of hydrocarbon sand, lakes at its poles, and perhaps deep beneath its crust, an ocean of liquid water mixed with ammonia. Huygens had transformed Titan from mystery to mirror, a place that reflected both Earth's past and its potential. Cassini's exploration of Saturn continued in ever-expanding arcs. Each orbit brought it through a different region of the planet's realm, past moons, through gaps in the rings, across polar latitudes. It discovered thunderstorms the size of Earth, roaring for months in the atmosphere. It photographed the strange hexagon-shaped jet stream encircling Saturn's North Pole, a six-sided vortex nearly 1,000 kilometers wide, spinning in place for decades, locked by fluid dynamics scientists still cannot fully explain. Cassini's instruments also detected lightning deep within the cloud layers, confirming that Saturn, like Jupiter, is alive with electrical storms. Over time, the spacecraft mapped the magnetosphere, the invisible field of charged particles surrounding Saturn, and found that it pulsed in rhythm with the planet's rotation, though not perfectly. This hinted at an internal complexity, perhaps deep interactions between the magnetic field and Saturn's core. The planet's radio emissions, captured by Cassini's antenna, sounded like cosmic music, rhythmic waves of plasma and magnetism rippling through the vacuum. But Saturn's majesty did not end with the planet itself. Its moons became Cassini's constant companions, each revealing an entire world. The small moon, Enceladus, only 500 kilometers wide, astonished scientists when Cassini's instruments detected jets of water vapor erupting from its south pole. The spacecraft flew directly through those plumes, finding salt, ice crystals, and organic molecules, the fingerprints of a subsurface ocean. The discovery transformed Enceladus from an icy pebble into one of the most promising places to search for life beyond Earth. Other moons added their own chapters. Mimas, shaped like the Death Star, scarred by a massive crater. Iapetus, half dark and half bright, spinning like a yin-yang of ice and shadow. Dione, Tethys, and Rhea, each tracing the subtle gravitational patterns that maintain the harmony of Saturn's ring system. Cassini discovered new moons, small shepherds orbiting within the rings, their gravity carving gaps and waves in the icy debris. It watched as ring materials spiraled into the planet in thin streams of dust and gas, ring rain falling into Saturn's atmosphere. The mission spanned 13 years in orbit, long enough to witness half a Saturnian year and the changing of seasons. As sunlight shifted from south to north, the planet's colors deepened and faded. Methane hazes thinned, revealing new structures in the atmosphere. The rings, tilted toward or away from the sun, went from glowing arcs to razor-thin lines slicing through darkness. Cassini's cameras captured eclipses, where Saturn's shadow engulfed the rings and backlit them in halos of gold and violet light, perhaps the most beautiful images ever taken by any machine. Through its long journey, Cassini became more than an instrument. It became a witness. It observed Titan's methane lakes sparkle in infrared light, saw Enceladus's geysers shoot hundreds of kilometers high, and measured Saturn's day length by listening to its magnetic heartbeat. It watched storms circle the poles and lightning flash through the clouds, and in one of its most haunting images, it turned its camera homeward. In 2013, Cassini photographed Earth through the rings, a pale blue dot framed by Saturn's grandeur. Billions of kilometers away, all of humanity fit into a single pixel. It was a reminder that exploration is never only about discovery, it is also about perspective. Behind every image was a human story. Generations of engineers, scientists, and dreamers who dedicated their lives to a mission that would outlive them. Many who began Cassini in the 1980s retired before its end. Some passed away before the final transmission. And yet, through every orbit, every correction burn, and every signal across space, their creation endured. A messenger of Earth among the outer worlds. By 2016, Cassini's propellant was nearly gone. Without fuel to adjust its course, it would eventually drift uncontrollably and risk colliding with Titan or Enceladus, worlds that might harbor life. To prevent contamination, NASA planned one final act, a series of grand finale orbits that would send Cassini diving between the planet and its innermost rings, a region no spacecraft had ever entered. These orbits would sample the composition of the rings and atmosphere, sending home data until the very last moment. The mission that had begun as an act of daring would end in sacrifice and revelation. But that part of the story, the final dive, would come later. For now, Cassini remained aloft in its cathedral of ice, still orbiting, still listening. The planet below turned slowly, its rings casting shadows across its face like the arms of a cosmic clock. After 20 years in flight, 13 in orbit, and billions of kilometers traveled, Cassini had rewritten the book on Saturn, transforming a distant jewel into a living, breathing world of storms, moons, and endless beauty. It was no longer just Saturn, the planet of myth. It was a system of light, and Cassini, its tireless observer, the poet who translated its language into human understanding. To look upon Saturn's rings is to witness one of nature's most perfect illusions, a structure vast enough to encircle the planet hundreds of thousands of kilometers wide, yet thin enough to vanish when viewed edge-on. They appear solid, smooth, almost architectural, like the grooves of a celestial record playing the music of gravity. But Cassini revealed the truth. The rings are not solid at all, but made of billions of particles, each tracing its own orbit in a vast ballet of ice and dust. Together they form a system of ethereal complexity, a living structure of motion and resonance. From afar, the rings seem timeless, an ancient crown worn since the birth of the solar system. Yet Cassini's measurements suggest otherwise. They may be younger than the dinosaurs, formed only about 100 million years ago, perhaps from the breakup of a moon or a captured comet shattered by Saturn's gravity. Each ring particle, ranging from dust grains to boulders the size of houses, reflects sunlight like crushed crystal. When Cassini passed behind the planet and looked back toward the sun, the rings shone like fire, a halo of frozen light. The main rings are named simply A through G. The broad B ring is the brightest and densest, while the Cassini division, a dark gap discovered in 1675, separates it from the outer A ring. Beyond that lies the faint F ring, a thin, shifting filament shepherded by two small moons, Prometheus and Pandora, whose gravity alternately pulls and compresses the ring's edges, creating ripples and braids that twist like silver ropes. Cassini's cameras captured these waves in exquisite detail, revealing structures only kilometers wide, proof that the rings are not static, but in constant flux. Closer in, The C ring and D ring shimmer faintly, their particles dustier and darker, perhaps remnants of material slowly raining down into Saturn's atmosphere. Indeed, one of Cassini's greatest discoveries was that the rings are not eternal. They are gradually dissolving. Streams of icy particles spiral inward, guided by magnetic fields and gravity, creating a phenomenon scientists call ring rain. The rain delivers thousands of kilograms of material into Saturn's upper atmosphere each second. In time, perhaps within a few 100 million years, the rings may fade away, leaving only faint remnants as ghosts of their former glory. Saturn, the Lord of the Rings, will one day be bare. Cassini's instruments peered not just at the rings, but through them. During stellar occultations, when distant stars passed behind the rings, its spectrometers measured how starlight dimmed, revealing the rings' internal structure and composition. They are made primarily of water ice, almost pure, mixed with traces of rock and organic compounds. The near purity of the ice suggests youth. Had they been ancient, micrometeorites and cosmic dust would have darkened them over eons. Instead, they gleam, clean and bright, as though newly born. The spacecraft also discovered propeller-shaped gaps within the rings, carved by moonlets only a few 100 meters across. These small bodies, too small to clear full gaps but large enough to disturb their surroundings, behave like embryonic moons, showing that Saturn's rings are a laboratory of planet formation. The same gravitational processes that once shaped the early solar system are still at work here, frozen in miniature. Each ringlet, each gap, is a relic of that primordial disk that once encircled the newborn sun. Beyond the rings lie Saturn's moons, a family of worlds that interact gravitationally, chemically, and electrically with the planet and its ring system. Cassini revealed that the line between moon and ring is often blurred. Pan and Daphnis, for example, orbit within gaps in the rings, their tiny gravity fields creating ripples that resemble waves on water. Cassini captured close-ups of Daphnis during its final orbits, a walnut-shaped world trailing plumes of ring particles like surf in slow motion. The boundaries between moon and ring, solid and fluid, blur into continuity. Everything here is movement. Among Saturn's larger moons, two became Cassini's most profound discoveries: Enceladus and Titan. Enceladus, only 500 kilometers across, gleamed brighter than fresh snow, a clue to its active surface. Cassini's instruments soon confirmed why. In 2005, it detected geysers of water vapor erupting from fissures at the moon's south pole. The spacecraft flew directly through these plumes, tasting their contents with its spectrometer. Inside were water, salt, silica grains, and complex organic molecules, the building blocks of life. Beneath Enceladus's icy crust, Cassini found evidence of a global subsurface ocean kept liquid by tidal heating. Within that ocean, hydrothermal vents may exist on the sea floor, just as they do on Earth, environments where life could conceivably emerge. Every subsequent flyby deepened the mystery. The plumes varied in strength, hinting at pressure changes within the ocean. Some carried nanograins of silica that could only have formed in hot water interacting with rock. Enceladus, a moon once thought dead, became a potential cradle of alien biology, its frozen surface concealing warmth and chemistry below. Cassini's data transformed it into a prime target for future exploration, perhaps even for missions seeking microbial life. Then there was Titan, Saturn's largest moon and one of the most Earth-like bodies in the solar system. Larger than Mercury, Cloaked in a thick orange atmosphere, Titan hides its surface beneath methane clouds and smog. Yet Cassini's radar pierced the haze, revealing rivers, lakes, and seas, not of water, but of liquid methane and ethane. Titan's poles glittered with hydrocarbon seas larger than the Great Lakes combined, while its equator stretched into dune fields of organic sand sculpted by wind. Cassini's instruments detected methane rain falling from the skies, feeding rivers that carved valleys into the icy crust. Beneath Titan's surface, Cassini found hints of another ocean, a deep, salty layer of water and ammonia that could conduct electricity. Combined with organic molecules in the atmosphere, Titan presents all the ingredients necessary for prebiotic chemistry. Its thick air, with a surface pressure 50% greater than Earth's, shelters it from radiation and meteor impacts, creating a world of slow, cold evolution, a laboratory of chemistry and time. Cassini watched Titan's seasons change over the years. As sunlight shifted from the southern to the northern hemisphere, clouds formed and dissipated. Polar lakes expanded and contracted, responding to the methane cycle, much as Earth's oceans respond to the hydrological one. Lightning flickered within storm cells. Titan breathed in rhythm with Saturn's long year, a living world sculpted by hydrocarbons instead of water. Everywhere Cassini looked, Saturn's moons were participants in a grand ecosystem. Enceladus's plumes fed material into the E-ring, maintaining its brightness. Micrometeorite impacts on other moons generated dust that contributed to faint outer rings. The gravitational interplay between Titan, Enceladus, and smaller satellites influenced orbital resonances that helped shape the ring system's structure. Even Saturn's magnetic field was connected to its moons. Cassini observed electrical currents linking Enceladus's plumes to the planet's auroras, an echo of the electromagnetic dance seen between Jupiter and Io. Through all these discoveries, one realization grew clear. Saturn's system is alive. It evolves not through biological processes, but through cycles of energy and matter, moons feeding rings, rings shaping moons, gravity orchestrating the dance. Cassini's long mission allowed scientists to witness that evolution in real time. It observed new features forming, dust storms spreading, and even subtle changes in the color and brightness of the rings as they shifted through seasons of light and shadow. In its data, Saturn's realm emerged not as a frozen relic of the past, but as a dynamic, breathing system where ice becomes vapor, vapor becomes ring, and ring becomes rain. The boundary between solid and gas dissolves, replaced by motion and transformation. Saturn, once the symbol of stillness and time, proved to be a planet of eternal change. To gaze at its rings today, knowing what Cassini discovered, is to see them not merely as adornment, but as story. A story of birth, decay, and renewal played out in the most delicate of cosmic materials. For all their grandeur, they may vanish in the cosmic blink of an eye. But through Cassini's eyes, humanity saw them in their prime, the jewels of the solar system, glowing against the blackness of space, reflecting the sunlight of a distant star that once gave them form. By 2017, after 20 years in space and 13 years orbiting Saturn, Cassini's time was ending. The spacecraft had orbited the ringed world 294 times, flown past its moons over 100 times, and transmitted more than 600 gigabytes of data. A treasure of discovery that would fuel generations of science. But its fuel was nearly gone. Without propellant to adjust its orbit, Cassini would one day drift uncontrolled through Saturn's system. And that could not be allowed. Not when worlds like Enceladus and Titan might harbor life. NASA's mission planners decided Cassini's fate with both precision and poetry. The spacecraft would end its life in a controlled plunge into Saturn's atmosphere, ensuring it would never contaminate the very worlds it had unveiled. The engineers called it the Grand Finale, a final series of 22 daring orbits that would take Cassini where no spacecraft had ever gone before, between the planet and its innermost rings. The gap was narrow, only 2,000 kilometers wide, but the gravity of Saturn pulled Cassini into that corridor like a thread through the eye of a cosmic needle. Each orbit brought it closer, sweeping through regions filled with microscopic ring particles and intense radiation. The spacecraft tilted its large, high-gain antenna forward, using it as a shield to protect its instruments as it dove repeatedly through the darkness. During these final orbits, Cassini became a probe of Saturn's interior. Its instruments sampled the density and composition of the upper atmosphere, measured magnetic fields, and sniffed the faint gases escaping from the rings. What it found astonished scientists: organic molecules, methane, carbon monoxide, ammonia, and silicate dust drifting from the rings into the atmosphere, proof that Saturn's rings were raining down upon the planet. This ring rain carried thousands of kilograms of material every second, changing Saturn's chemistry in real time. For the first time, humanity was watching a planet consuming its own rings. Cassini's gravity data also revealed new details about the planet's interior structure. Beneath the clouds, Saturn's core was far larger and more diffuse than expected, a fuzzy sphere of rock and ice extending 60% of the way to the surface. Its rotation period, long a mystery, was pinned down more precisely by tracking variations in its magnetic field and radio emissions. The spacecraft also confirmed that Saturn's magnetic axis was almost perfectly aligned with its rotation, a mystery unlike any other planet, defying the usual models of planetary dynamos. But perhaps the most breathtaking of all were Cassini's final images. As it passed through the shadowed side of the planet, the spacecraft looked back toward the sun, capturing Saturn backlit in glory. The rings glowed like halos of fire. The planet itself became a dark crescent rimmed with light. In one of these images, taken in 2013, but revisited in Cassini's final months, a tiny blue dot could be seen suspended among the rings. Earth, our home, glimpsed across 1 billion kilometers of space. It was a quiet, humbling reminder that the same sunlight illuminating Saturn's rings also shone on us. Each orbit of the Grand Finale was a descent into both danger and revelation. Cassini skimmed just above the clouds at nearly 120,000 kilometers per hour, enduring temperatures and radiation that tested its every system. The data it sent home in those months were pure gold. The mass of the rings, their precise composition, their decay rate, and hints of complex atmospheric chemistry on the planet below. Scientists discovered that the rings were lighter than expected, implying that they were not ancient relics from Saturn's birth, but young and transient, perhaps formed from the remnants of a shattered moon or captured comet only tens of millions of years ago. Saturn, in other words, was still in the act of creation, its rings a temporary sculpture of ice and gravity. As Cassini's fuel reserves dwindled, the team planned its final orbit. On September 15, 2017, after one last pass between the rings and the planet, the spacecraft's trajectory was adjusted for a direct entry into Saturn's upper atmosphere. There would be no return, no rescue, only data transmitted in real time until the signal vanished forever. The final commands were uploaded from Earth, a sequence of instructions that would guide Cassini's final moments like a script for a cosmic finale. The night before the end, mission control at the Jet Propulsion Laboratory was alive with quiet tension. Some of the engineers who had built Cassini decades earlier were now gray-haired. Others had joined as students and were seeing their first mission end. Screens glowed with telemetry, graphs, and live updates from across the solar system. Cassini was more than a machine. It was a generation's companion, a metal explorer that had revealed a world of unimaginable beauty. At 4:37 a.m. Pacific Time, Cassini's antenna locked on Earth for the last time. As it plunged into the atmosphere, its thrusters fired constantly to keep the antenna aimed homeward, fighting the thickening air. Sensors recorded pressure, temperature, and composition: helium, hydrogen, traces of methane, the first direct samples ever taken from Saturn's upper layers. As friction increased, the spacecraft began to heat. Telemetry showed the thrusters working at full force, compensating for turbulence. At 4:55 a.m., Cassini's signal began to fade. The spacecraft was more than 1 billion kilometers away, but on Earth, its radio heartbeat came through the deep space network, a faint tone, steady and pure. It continued for 45 seconds, then suddenly cut to silence. Cassini had become part of Saturn, a flash of metal and light dissolving into the golden clouds. In that moment, a world said goodbye to its messenger. The control room erupted, not in sorrow, but in applause. Tears flowed freely. Engineers hugged. Scientists stood in reverent silence. They had guided a machine through 20 years of space, watched it fly past Venus, Jupiter, Titan, and Enceladus, and then watched it fall, not as a failure, but as a final gift of knowledge. In its last seconds, Cassini transmitted data that would take months to fully decode, a scientific epitaph written in the language of physics and light. From those final measurements came insights still unfolding today. Cassini's entry revealed that Saturn's atmosphere is rich in complex organics, delivered by the decaying rings and perhaps by meteoritic infall. It mapped temperature gradients, wind speeds, and pressure layers far more accurately than ever before. Its measurements of magnetic and gravitational fields refined models of the planet's deep interior, how it rotates, how heat flows, how hydrogen transitions to metallic states. And as scientists continued to analyze the data, new questions emerged. How exactly do the rings die? Could new ones form again someday? What do Saturn's moons teach us about exoplanets orbiting distant stars? Cassini's legacy is not only the data it sent, but the vision it inspired. Its journey redefined what a space mission could be, not just a brief encounter, but a long companionship with a planet. Over 13 years, it showed us that exploration is not only about discovery, but about relationship, about listening to a world long enough to understand its rhythm. Saturn's storms, its moons, its rings, all became part of the human imagination. Through Cassini, we learned that beauty and science are not opposites but allies, that to measure a world is also to love it. As its remains sank deeper into the clouds, Cassini became what it had always been destined to be, stardust once more. Its atoms mingled with the gases of Saturn, scattered by winds into the banded atmosphere, its metals dissolving in hydrogen seas. One day, perhaps billions of years from now, those same atoms may fall deeper still into the pressure-forged heart of the planet, and there remain a trace of humanity preserved within the Lord of the Rings. In the darkness beyond Saturn, the sun burns faintly, a distant star framed by the planet's glowing rings. That light, traveling across 1 billion kilometers, still carries the echoes of Cassini's final transmission. It reminds us that exploration is never truly over. Every ending in space is a beginning somewhere else, in a new mission, a new question, a new dream of what waits beyond. Through Cassini's eyes, we saw a universe not of cold emptiness, but of light, movement, and connection. And as its final signal faded into the static of the cosmos, it left behind not silence, but a legacy of wonder, the enduring truth that even in the farthest reaches of the solar system, humanity can find beauty, purpose, and belonging among the stars.